Welcome to this online lecture about valence electrons. Valence electrons are incredibly important to chemistry because valence electrons are how different atoms interact with each other. Valence electrons are what the part of one atom that encounters another atom when they kind of get close together. It's really important that you know what a valence electron is, and that for any given element you can quickly determine how many valence electrons that it has, because later in class when atoms start combining to form compounds, it's the number of valence electrons that determines if and how they will interact with each other to form compounds. So let's get going. The previous video was about the electron cloud and the configuration of the electron cloud, and we learned that the electron cloud is organized by main energy level, sublevel, and orbital. Well, the valence electrons are really about that main energy level. Now, I explained in the last lecture that for any given atom, the main energy level might be anything from 1 to 7, and that an electron cloud might actually have several main energy levels in it. It might have main energy levels 1, 2, and 3, or it might have main energy levels 1 and 2, or maybe just 1. Well, valence electrons are electrons that are in the highest main energy level for a given atom. Highest main energy level for a given atom. So let's look at two examples. I'm going to pause the video and write out two electron configurations for two different electron clouds, and we're going to look at what I mean when I say highest main energy level. Okay, I'm back. And as you can see, it looked like it happened instantly to you, but I took some time and I wrote out the electron configurations of the electron clouds of an oxygen atom, right here, the electron cloud of an oxygen atom, and then underneath it I wrote out the electron cloud of a chromium atom. So you can see that oxygen's electron cloud has a main energy level 1 and main energy level 2. Chromium's electron cloud has main energy level 1, 2, 3, 4. And then there's a 3 over here again. Interesting. So the definition of a valence electron is an electron that's in an atom's highest main energy level. So let me get my blue color here. And what's the highest main energy level in an oxygen atom? There are only two main energy levels. There's main energy level 1 and main energy level 2. So 2 is that atom's highest main energy level. So how many electrons are at the second main energy level in the electron cloud of an oxygen atom? And the answer is there's 2 in the S sublevel and there's 4 in the P sublevel, so there are 6. There are 6 electrons in oxygen's highest main energy level, and that means that oxygen has 6 valence electrons. But let's look at chromium, because chromium is a little weird. Chromium has energy levels 1, 2, 3, and there's a 3D over here, and 4. So the highest main energy level in a chromium atom obviously is 4. And how many electrons are in that highest main energy level? There are 2. So that means that chromium has 2 valence electrons. So for us to figure out with these two examples how many valence electrons these elements have, I actually wrote out the configuration for each element's electron cloud. But guess what? There's really good news. You don't have to do that every time you want to know how many valence electrons an element has. So I just brought in our periodic table here, and we're going to take a peek at the periodic table, and I'm going to show you that there's a really nice pattern to these valence electrons. So oxygen was one of my examples, right? And oxygen's right here on the periodic table. And notice its group number, 16. And notice how many valence electrons it has, 6. Here's the pattern. If you start at the left of the periodic table, at first the group number tells you the number of valence electrons. all the elements in group 1 have 1 valence electron. All the elements in group 2 have 2 valence electrons. As a matter of fact, all the elements in group 2 through 12 have 2 valence electrons. And then when we hit group 13, they all have 3 valence electrons. All the elements in group 14 have 4. And then group 15 has 5. Group 16 has 6. And group 17 has 7. Now, an interesting thing about the way that the electron cloud is configured is that the most valence electrons any element can ever have is 8. And at that point, the valence shell of the electron cloud is full. So this group 18 right here, they all have 8 valence electrons, which means that they're full. They couldn't hold any more valence electrons if they wanted to. The idea of there being 8 valence electrons max is pretty important, because eventually when we start talking in this class about atoms forming bonds, we're going to be talking about them trying to get the maximum number of valence electrons. So that's pretty important, that 8 is the max, and that this column in the periodic table, the noble gases, already have the maximum number of valence electrons possible. So that's just a really quick little lecture on how to determine the number of what a valence electron is, and how to determine the number of valence electrons for any element. As always, if you have questions, you can ask in class, and thanks for watching.